In 2024, construction workers digging under a traffic-choked highway in London struck a massive stone barrier just 15 inches below the asphalt. Workers had hit Watling Street, a Roman military highway built in the year 43, still solid enough to support the weight of heavy double-decker buses. While the modern road on top requires constant expensive resurfacing to survive the winter, the underlying stones haven't shifted a single inch in 2,000 years. Modern civil engineers have access to heavy machinery and synthetic sealants, yet their highways are designed to fall apart in just 20 years. Rome built over 400,000 kilometers of roads across steep mountains, damp forests, deep swamps, and burning deserts. Soldiers accomplished this feat using hand tools and local materials. Many of those roads remain visible today. Some serve as the direct base for Europe's busiest trade routes. Permanence depended on conquering a single invisible enemy that modern road builders choose to accommodate. Constant moisture is always at work, waiting to destroy the pavement from beneath. As the empire expanded, speed became Rome's ultimate weapon. Roman legionnaires marched 30 kilometers a day in heavy armor through mud and snow. Dirt paths quickly turned into impassable swamps under thousands of marching boots, stalling critical reinforcements. To solve this, Roman generals treated roads as vital military infrastructure requiring permanent engineering. Specialized surveyors used a sighting instrument called a groma to align these paths in straight lines. Straight routes minimized travel times for troops but presented massive engineering challenges. Instead of going around obstacles, engineers cut directly through hills and built stone viaducts over deep valleys. Eventually, the network stretched from Scotland to the deserts of Iraq. At its height, the network included 80,000 kilometers of paved highways and 320,000 kilometers of secondary roads. These trade routes defined the economic map of Europe for centuries. Drivers on England's modern A419 highway are travelling directly on top of the ancient Ermine Way. Sections of the Fosse Way from Exeter to Lincoln still form the spine of several modern British roads. As modern asphalt wears thin, the underlying Roman stones reappear, stubborn and unmoved. To understand why these ancient structures outlast modern concrete, we have to look beneath the surface. Today's highways are thin layers of gravel and asphalt spread over compacted soil. Engineers build them for speed and low initial cost, expecting resurfacing every 15 years. The Romans built their roads like fortresses. Workers dug a deep trench, called a fossa, down to solid bedrock. Where the soil was swampy, they drove thick oak piles into the ground to create a stable platform. For the foundation layer, or statumen, workers used large stones bound with clay or lime mortar. This 2-foot-deep base kept the road from sinking under heavy military wagons. Next came the rudis, a layer of broken stones and mortar rammed down by hand. Above that, they spread the nucleus, a bedding layer of fine gravel and broken tiles. Paving the surface with the summum dorsum required large blocks of volcanic basalt. Individual stones were shaped like wedges and fitted so tightly that a knife couldn't pass between them. Roman roads reached up to 5 feet in thickness, whereas modern interstates are rarely thicker than 18 inches. Yet thickness alone doesn't explain their survival. If the Romans had only relied on massive stone, the roads would have washed away in a few winters. Builders had to defeat the single most destructive force in civil engineering. That force is water. Mixing volcanic ash, known as pozzolana, into the mortar created a chemical reaction with lime and water. Such chemistry allowed the cement to harden even in damp environments. Recent scientific studies revealed that this concrete contained small white chunks called lime clasts. When cracks formed and water entered, it dissolved the calcium in these clasts. Once inside the gaps, this calcium-rich solution recrystallized, effectively healing the structure from within. But the self-healing chemistry was only the second line of defense. The primary victory was keeping the roadbed dry. When water penetrates a modern road, it pools in the soil below. Heavy traffic pressurizes this water, forcing soil particles out and leaving hollow cavities. During winter, the water freezes and expands by 9%, cracking the asphalt from within. Once the ice melts, a hollow space remains, collapsing into a pothole under the next heavy truck. Asphalt remains porous, trapping moisture that eventually destroys the road. Instead of keeping water out, the Romans engineered the road to let water pass through and escape. By curving the surface, they created a camber that forced rain to slide off the paving stones immediately. Deep drainage ditches on both sides kept the runoff far away from the foundation. Their most brilliant innovation was the gravel base. Because the lower layers were porous, any water that seeped through drained straight down, away from the roadbed. Runoff flowed into the side ditches, leaving the foundation dry and stable. Contemporary roads are built to be cheap and fast, relying on budgets that prioritize short-term savings. Building a Roman-style road today would be astronomically expensive. A single mile of modern highway can cost $10 million, yet it is expected to fail within a generation. Rome built for eternity because their empire depended on permanent connectivity. Ancient builders of Watling Street didn't know their work would survive to support double-decker buses in 2024. They only knew that if the road failed, the legion wouldn't arrive in time, and the empire would fall. Today, the ancient paving stones sit quietly under the rumbling tires of London traffic. Meanwhile, the modern asphalt above them continues to crack and dissolve with every winter. Which piece of modern infrastructure do you believe will survive 2,000 years after our civilization is gone?